Hello. Hello and welcome to clear your throat before you start recording. Yeah. Welcome. Welcome to another nostalgic math ramble. We are looking at the department's May 2023 paper 1. Yeah, let's ramble. Question 3. A quadratic sequence has the following properties. The second difference is 10. The first two terms are equal, i.e. t1 is equal to t2, and t1 plus t2 plus t3, so the sum of the first three terms is 28. Show that the general term of the sequence is tn is equal to 5n squared minus 15n plus 16. Okay, cool. So let's talk about quadratic sequences also, because I need to refresh my memory. So quadratic sequences have a general term that look like this. Right, and in this case we know that a is 5, b is negative 15, and c is positive 16. We need to show that that is true. Right, so I just want to talk myself through the basics of quadratic patterns. So with a quadratic pattern, t1 would be a times 1 squared plus b times 1 plus c, which is a plus b plus c. And t2 would be a times 2 squared plus b times 2 plus c. Which is equal to 4a plus 2b plus c. And t3 is a times 3 squared plus b times 3 plus c, which is 9a plus 2b plus, not 2b, 3b. And then just for here, so let me do term 4 as well. Okay. So that is 16a plus 4b plus c. Okay, so now, oops. If I write these down, so term 1 is a plus b plus c. Maybe let's move this even further out actually. Then the first difference is, right, the difference between the respective terms will be, in this case, 3a plus b. The next one is 5a plus b. The next one is 7a plus b. So essentially, how much am I adding to go from here to here, from here to here, from here to here? Okay, and then the second difference is how much am I adding to go from here to here, and that is 2a. And from here to here is another 2a. Okay, so the second differences for the quadratic pattern will always be 2 times whatever a is. The first difference will be 3a plus b. The second first difference will be 5a plus b, and so on and so on. Okay, cool. Right, this is all coming back to me a little bit. Just a little bit. Okay. Right, so now, having armed myself with all this knowledge, let's look at this question again. So, first point says the second difference is 10. So what that allows us to do is to say 2a is equal to 10, right? Because we know that the second difference is constant. It is 2a for any quadratic pattern, and so in this case our 2a is equal to 10, which tells us that a is equal to 5. Awesome. Then the next piece of information tells us the first two terms are equal. So the first two terms are equal, which tells us that this and this are equal. So let's just quickly set up an equation. So we have a plus b plus c is equal to 4a plus 2b plus c. And we know that a is 5. So we got 5 plus b, and there's a plus c on both sides. So not really adding anything to the equation scale. We can cancel those out. Or in more technical terms, subtract c on both sides and the equation is still perfectly fine. So then we substitute the 5 in here as well. So we've got 5 plus b is equal to 20 plus 2b. And that is 5 minus 20 is equal to 2b minus b, which means minus 15 is equal to b. Okay, and so far so good, because we are expecting a to be 5 and we got a is equal to 5. We're expecting b to be minus 15. We just got b to be minus 15. So the last guy is 16. Okay, so let's see. Presumably we can use this last piece of information to figure out the value of c. So we have t1 plus t2 plus t3 is equal to 28. So we're going to add t1, t2, t3, and that should give us 28. Okay, so first I will shrink some things. Okay, so we've got t1 plus t2 plus t3 is equal to 28. So that is 14a plus 6b plus 3c is 28. We now have the value of a is 5. The value of b is negative 15. The value, we don't know what c is. Right, so that is 70 minus 90 plus 3c is equal to 28. Okay, so that's negative 20 plus 3c is 28. So 3c is equal to 28 plus 20, which is 48. And then that means c is 48 over 3, which is 16. Hooray, hooray, hooray. Oh my goodness, not so hooray. Okay, let's see what we can clean up. Right, okay, so move that out too soon, but we would then say, therefore Tn is equal to 5n squared minus 15n plus 16. That would be the last. Let me write that down. There we go. Right, and so we're asked, next question, is 216 a term in this sequence? Justify your answer with the necessary calculations. Okay, so if 216 is a term in the sequence, that means that there is some number n such that 5n squared minus 15n plus 16 is equal to 216. And more specifically, it's not just any number, it has to be a natural number, because we know that n represents the position of a term in the sequence. So you can't have a term in position 1.5 or a term in position 100, 0657. So if we can find some natural number n such that 5n squared minus 15n plus 16 is equal to 216, that means that 216 is in fact a part of the sequence, and it occurs at position whatever n is. So let's solve this quadratic equation here and see what result we get. Okay, all the terms look to be divisible by 5, so I'm just going to divide by 5 the whole equation, just because I like factorizing, but of course you could solve this using the quadratic formula. And this looks factorizable, it's giving, yeah, so 8 and 5 look like they can work. So we've got n minus 8 times n plus 5. Yeah, that looks good. Yep, that looks good. So therefore, n is equal to 8 or n is equal to negative 5. Okay, but only we know that n is some number bigger than 0. So n is equal to 8. And therefore, yes, 216 is a number in the sequence. Okay, it appears at position 8. Okay, awesome. Let's double check with the memo. Question 3, we do, okay, so the showing went well. We arrived at what they were expecting. And yes, T8 is equal to 216, so good and well.